Good morning. Let's start the last module 5, RTOS and IDE for embedded systems design. So here the RTOS stands for real-time operating system, whereas IDE stands for integrated development environment. So here in the last session we have seen module we have seen how is the RTOS works, okay, and how the IDE works we have seen in our lab program, that's using a Keel software. Okay, now we are mixing both the concepts so that we can design one embedded system properly. In that, so we have some 3 chapters in this module 5, that's chapter 10 and followed by 13 and 12 and 13. So first let's go for chapter 10, RTOS based embedded system design. Okay, for your information, let me tell you something that this chapter 10 is of your operating system subject kind of summary or almost related to the subject or concepts what we have studied in your operating system. Okay, so almost same concepts, little small deviations here and there. Okay, so let's start the first point, operating system basics. Okay, so we all know that the examples of operating system in our computer or a laptop as Windows 10, Windows XP. Okay, so then in our mobile we have Android, okay, Symbian OS, etc. So now what is the main point or main purpose of operating system? It establishes a communication between user and the hardware. Hope you all know in your operating system how the user will get work done by using the hardware of a system. Okay, hardware not only means computer hardware, even it means ATM machine hardware, mobile hardware, etc. So every system or every embedded system has its own and dedicated hardware, and user can use the hardware and make the work or get the work done by the hardware. So now the question, user doesn't know the hardware language, which is a ones and zeros, which we call it as machine level language, and the hardware, which we call machine, doesn't know the English or the button or the options what user is going to perform. So there is some intermediate step who is going to establish communication between two unknown ends, that's the user end and the hardware end. Here in the every embedded system, it's a duty of operating system to establish perfect communication so that user feel comfortable to use the system, and also his work should be completed on the time. So let's take one example. So I want to withdraw some money from my account. So what is a traditional method? Traditional method is to go to the bank branch, write one slip, okay, and wait in the queue. If the amount is available, they will give the cash they will give the amount in terms of cash. We can go for the further steps. Okay, so now how it is replaced with the hardware? Okay, so here it is replaced with the system called ATM. Okay, so what here user will do? Okay, he has given with one access card. So through that card he will give the password, and that ATM machine will check whether the sufficient amount is there or not in the user account. If amount is there, that much amount is withdrawn and given. Also the database of that person or a user account is updated. See here, the hardware, the purpose of ATM is to reduce the time taken and efforts of the user to get cash from his account. Okay, so that is successfully fulfilled because he not only he has to visit a bank, okay, so he is waiting in the queue and writing a slip. All works are reduced. Nowadays to transfer a money, not even need to go visit a ATM. We have a mobile device and a UPI code, that means phone pay or a Paytm. through which instantly we can transfer amount from one end to the another end. So these all activities are basically controlled by operating system. Okay, so what makes what are the benefits of one operating system is, one is it makes the system or work easier. Okay, so if we don't have the Android OS or the mobile device or mobile related equipments, so it was not possible for us to today transact in via phone pay or any other. Okay, so we had only option through internet banking. Okay, so like that we used to carry always our laptop or a computer with us, account number. Okay, so nowadays no need of account number, no need of IFSC code, directly we can send a money from one person to another person, one account to another person. See that here, because of OS exist, we have developed applications for finance transactions. Because of usage of applications and corresponding OS, the transfer of amount became very easier. And all the type of works in our mobile, like taking a printout, downloading a file from the internet, sending a message, playing a music in mobile, see, all these works are managed well and executed at a time. Even though we execute such all the activities at a time, no problem we will face in the during such a situations. Okay, even though there are plenty of works executes at a time, still the Android or the operating system what we are using will take care that there won't exist any of the deadlock situation. I hope you know the definitions of a deadlock and technical explanation related to the deadlock in your operating system. Okay, so here is one of the diagram, a conceptual view of how the user application executes on a hardware. See, user application, he will take help of all these sub steps or subsystems using particular management units. Okay, these all will execute, they all will take care such that user application runs on the hardware successfully. See, some of the applications doesn't need a memory, some of the application need a memory. Okay, or 90% of applications definitely they will take help of memory in the embedded system, also in the computer. So if to execute a task memory is required, definitely we need a memory management unit participation. See here in the diagram, first the user application takes the help of memory management. So the user application is not only single process, it will be a two or more sub processes or a smaller processes. So we need to manage them by allocating a resource, by scheduling them, by synchronizing the process, so that user feel the task is completed. Internally, a main task of user is subdivided into smaller processes. Okay, all those smaller processes are well executed to give one particular result which user is expected. In the same way, there is a concept called time management. Hope we have this example may be the correct one. So I want to transfer amount for my friend using one phone pay app or a Google Pay. So what I do, I will select the account contact number, and I will give the amount, and also I will give the password. It will wait for some 45 seconds or 60 seconds. If the transfer success, it's done. If not, see the now with respect to that time of a 60-second limit, it will show the amount transfer is not possible to execute because resources are not available right now. So try little later. Like that, it will give some kind of error or some messages. See, file system management and IO system management. So all the data, all the content processing in the embedded system, also in a computer, is in terms of files. The file may be MP3 file, text file, image file, video file. Okay, so many types. Anything we have, it is in terms of file. So if you want to execute or get the work done by a computer or an embedded system, definitely it is execution of a file. If we are working with a file, definitely there should be some managing unit with respect to the files. So that is called as file management unit. Same way for IO. input output. So user will give input like contact number to whom I want to send a amount, pin number which I have set already. Output means the date, I mean money transferred successfully, and I will get one receipt or acknowledgement number and amount deducted from my account. These all are the outputs. Okay, so here input output with respect to audio. If I want to search something in the YouTube, so what I will do, search for operating system concepts, like that. This is a voice input, and it will also give the files related to that. Okay, that is kind of output. So meaning is what, if a person or a user wants to get work done by a computer or embedded system, all these sub management units should participate such that user will get a perfect output from the perfect output for expected task. Okay, so that is what small basics of the operating system. So we have some of the definitions which we have studied in our OS also. So what you mean by the kernel? Kernel is core of the operating system which will manages processes and resources and their synchronization, utilization of resources, so that a process execution will complete. One simple thing for kernel is, it is a main person who is taking care about happenings in the embedded system, also in the computer system. So if there is a no kernel, definitely we cannot expect a good output from the embedded system, any embedded system it is. Okay, next comes primary process management. Okay, what you mean by process management, you have studied in operating system. So if there is one process or any process, it should be managed properly. What do you mean by process management? Whether the process creation is success or not, that should be managed. Once process is created, whether the requesting whether it will request for a resource, whether they are available or not. If available, give them. If not available, when they are going to be available for that particular process, and after that synchronization of a process with each other. Okay, then managing a input output corresponding to that process. Okay, like this everything related to process is managed by process management unit. In the same way, we have memory management unit also. So we have two type of memory. One is a RAM, another one is a ROM. Generally we call RAM as a important kind of a memory which should be managed properly. If we don't manage a RAM correctly, so definitely what happens, it affects efficiency of the embedded system. So it is important to manage the memory type. As I told, primary memory means RAM. Okay, so if we want to execute some Android Studio which is of 8 GB, and if we have our RAM exactly 8 GB, so some of the part of RAM which is not used, not in the present usage, should be removed out, and the RAM should be given for a particular software who needs right that moment. So for that it should be allocated. Unwanted or not used process or data should be removed from the RAM, and which are currently executing, those should be allocated with the RAM. This is done by primary memory management unit. As I told, file system management unit, everything in computer as well as in embedded system is in terms of files. Okay, every file, exe file we have, then text file we have, then ASM file we have, then output file, object file. See, all these are in terms of files only. Okay, so sometimes what happens, if I execute one program, 4 type of files will automatically created. Okay, if you execute one keel program, so you will get 4 type of files: hex file, object file, ASM file. Okay, so these all are the subtype of files. Okay, even if I remove one profile, it may affect the original file and its execution. So who is going to manage all these activities? It's a file system management. In the same way, we have input output devices management. What are the general input output devices? Keyboard and monitor. Okay, see now one case, there are 3 processes executing, process A, B, C. Presently whatever I type is for process A. Suddenly process A is swapped out process B is swapped in and I am unaware and still I am typing. What happens? Whatever I type will be given for process B. Actually for process A I am typing, but it is given for process B. See this mistake. This mistake should not take place. Now who is taking care about all this? The IO device synchronization with respect to process is IO device management. Okay, so next one is interrupt handler. I hope you all know this from the previous OS subject or chapters, that what you mean by interrupt is it's one process is executing, suddenly another process with some more importance will comes for execution or occurs for execution. So what we have to do, we have to stop already executing process, store its data in the stack and give the space and resources for the newly arrived process. Let it get executed. Once the high priority process completes its execution and it is moved out from the processor, again take back the old partially executed program from the stack and load its related data and constants on the particular registers and continue the execution. For this I have gave many example. Still I would like to give you is, say assume that you are watching a TV sports, you are watching some sports, suddenly you are holding a remote. Okay, suddenly your father will come or your mother will come to in front of that TV. So what is your duty? You have to hand over that TV remote to your parent and you should go back or you should sit whatever he is watching or mother is watching, that you should join. So what happens after his work is completed? He will hand over back your he will give back remote to you. So what you will do? Again you will switch back to that sports channel and you can watch. See, this is what concept called as interrupt. Here you should handle interrupt properly. Okay, now there are two things with respect to the space in the memory. One is a kernel space and user space. Kernel space means all the essential and program related area, where program related contents stored in the space, that is called as kernel space. The contents or the programs related to user where they are stored in a memory, that area is called as user space. Very simple way to discriminate is, if you relate is, if you check a classroom, there is a dais, that is a space for teacher. There is another space for students where there are plenty of benches. That space is called as a student space. Okay, hope you understood. So one who gives a lecture should be on the dais, one who is listening should sit on the benches. So this is how to identify the spaces. Same way, kernel space means related to OS or the service, some processes related to service, whereas user space means processes or programs related to user application, that is called as user space. There are two types of kernel. One is a monolithic kernel and a micro kernel. So monolithic kernel meaning is, here there will be two areas. One is a user space, here you can see application, and another one is kernel area. Okay, this kernel space will include not only right now essential, it includes all the data whichever is required for executing a program. So that is a monolithic. If you study microkernel, easily you will identify the difference between monolithic and microkernel. Okay, and all the services are stored in the kernel space, and these are tightly coupled. Please remember this, tightly coupled, because there is no other space left out. So we have to store everything in this kernel space. So which type of OS uses a monolithic kernel? We have to remember Linux and Solaris. Okay, so coming for the next microkernel. So what you mean by microkernel is, here the space is divided not only into two categories called as, one is a user side, another is kernel side. It is divided into three sectors. One is a user side called application, another is a microkernel, and third one is a server. This is very popular in our day-to-day life. Hope we all are aware that VTube server is there, Google server is there. Okay, so that means what here, user via server he will request for a resource or some data. Okay, not all the time it is compulsory to store all the data related to program or a process in only single space. It's a distributed architecture. So set of services are stored in a server, set of data is stored in a kernel. Okay, and another side user application will be there. So what user will do, user want to fetch a data from this kernel. So what he will do, general tendency, through server he will request the data. Sometimes data is possibly to give directly to the user, sometimes through server the service is provided. Through server the service is provided. Here what is one type of advantage is the architecture is distributed. Here in the previous architecture is centralized. This kernel space is overloaded. Whether it is essential or optional data, everything is loaded in only one set of kernel area. But here optional data is stored here, essential services, here is a data and service are stored in the servers. So what is advantage of having a microkernel is 2 points, robustness and configurable. We can configure the server. Okay, we can configure the server according to our requirement. Okay, so that we can get any type of quality of a service from the server. What you mean by robustness is, if we are unable to get a direct communication between user and kernel space, and that is difficult at some time, we can get the same service via servers. If server fails to give the service, they automatically correct themselves and immediately they will start providing the service. Hardly we have heard about the server down for Google or something. So they will automatically robust, they will repair themselves and continue providing the service. Okay, so next we have is types of operating system. Okay, there are two types. One is a general purpose operating system, another one is a real-time operating system. This module concentrates on second concept, that's a RTOS. Okay, what do you mean by general purpose? Very simple, it is used in non-time critical systems. Non-time critical systems. What do you mean by non-time critical systems? Okay, remote car of a kid. Okay, so remote car of a kid which is inbuilt with the OS, our home desktop application. Okay, like a Windows 7, Windows 10, XP, like these all are called as real general purpose operating system. There is no time limit, even though they respond 10 seconds later, 2 seconds later, nothing harm will affect to the society. So you are giving some print command, so print is taking 1 minute extra time, so it is not going to affect anything. Okay, so that is called as general purpose operating system. So what is another category? Real-time operating system. This is important. If their response is delayed, something harm will happen or something loss will happen to some type of a user. So such a systems will use real-time operating system, like share market servers or the computer which we are using in our nuclear power plant units. So if they won't give response on time, means delayed response, definitely it will harm or damage the system. The OS which is used in such an environment is called as RTOS. Even our mobile is also real-time operating system. Okay, so next, what you mean by real-time kernel? So real-time kernel means the operating system which is a real-time, its kernel is called as real-time kernel. What you mean by general purpose kernel? The operating system which is general purpose, okay, its kernel is called as general purpose kernel. The kernel of RTOS is real-time kernel. So what are the services or functions that RTOS kernel will do? These are the 7, and this will be the different question in examination. Explain in detail types of OS, and the actions or the functions of real-time kernel. There are 7 actions or functions of real-time kernel. What is the first one? Task or process management, task scheduling, task synchronization, error handling, memory management, interrupt handling, time management. All these you have studied in your OS. Okay, just for definitions or for explanation purpose we will study. So more about this you have already studied in your OS subject. Okay, so what do you mean by process management? As I told, so anything we want to do in a computer or embedded system, definitely it will be in terms of bunch of processes. Sometimes one process, two process, or many of the processes at a time. Okay, so here if a process is if you want to get the work done by a process, so first thing we should create that process. If you want to create a process, we should aware that we have to use a limited set of resources, and we have to use minimum resources and check whether that resources are available or not. If not available, process creation should be postponed. Okay, like that all these activities should be managed properly. Who is going to do this is process management unit, nothing but OS. Again it comes to the kernel. Okay, OS is not like a part of OS is a kernel. That kernel will take care about process creation, continuation, its execution, waiting, and again continuation and termination once it is finishes the execution. So how the process management will manages every task, because task means there will be multiple processes at any instance of a time. Okay, see now every task will have following details. See, every task is process management unit will store following details about each and every task, so that it will be easy for process management unit to manage all the processes. What are the factors or the details about each task is stored is task ID. It's a unique number like USN for a student. Task state, in which state the present task is. I hope you know this diagram. Let me show you. See this diagram. Created, ready state, running, blocked means wait, then completed. This you have studied in your OS, same diagram. Okay, among these states, in which state the task is, task type. Okay, this you might have heard first time. Hard real time and soft real time. Hard real time means process should execute whatever its exact time. There is no compromisation, and compromisation with respect to time is not allowed. Whereas a soft real time means the relaxation, there is a small relaxation. Even if it execute 10 seconds late or 10 seconds early, 25 seconds late, early, some 1 minute late and early is allowed. Soft real time means flexibility is there. Hard real time means exactness is there. Whenever we want a quality of service should be high, then we should think about hard real time. Soft real time means adjustable or flexible quality of service. Task priority. Why this point is important? If the task is low, okay, some other process with a high task may come and it will get interrupted, okay, or preempted. Whereas if the priority is high, it is going to replace the process, other process. Okay, so for that reason the kernel or process management should know whether priority of each process is important. Say one thing is if the priority is not known by the management unit, then there not exist a concept of interrupt. Okay, so all process will come on in the sequential manner, they will execute. Even if it is important, it is not possible to execute because there is no word of priority. So priority is a very essential concept. Memory pointer. So a particular as I told, always a process uses particular block of a memory, correct? So which block is related to which process, so that is related by pointer. Okay, for a program, which part of memory it is utilizing, there it will create one pointer and make it pointing, so that whenever a process wants a data, it will fetches using that pointer. So next one is resource pointer. As I told, here is a memory, the set is, another set is resource. Process 1 wants keyboard, so then there will be one pointer for managing a keyboard with respect to process 1. If process 2 want some modem, then again process 2 will work along with the pointer related to the modem. That's what the concept of a resource pointer. And other parameters, now along with these, some special parameters like how much time it is going to execute, what all the other resources it may use, like that extra information is also stored with respect to every task. This is what first task of a real-time kernel. Here, that is what we finished. The rest all you know. These I have listed very small statement because you know these in your OS subject. Process scheduling. What do you mean by scheduling? Scheduling means giving the process their requested resources on that particular amount of time using some discipline. Discipline means some algorithm. You might have heard about first come first serve, shortest job first, shortest remaining time, priority based algorithm, and round robin. Based upon these discipline or algorithm, a process and set of process and set of resources are mapped with each other and they get execution. The activity of giving particular resource to particular process is called as process scheduling. Now who is doing this is called scheduler. Okay, so scheduler will use one of the algorithm from this list and implement the execution of the schedules the process execution. So what do you mean by tasks synchronization? Task should be synchronized with the resource. Say for example, process A wants monitor at some particular amount of a time, like 10 AM in the morning, to show the output. Or example, at exactly at 10 AM, process 1 will finish and it will give print command of 25 pages. Okay, so 10 AM. Suddenly what happens at 10 o'clock and 5 seconds, some other process will come and it will also give a print command. See, the synchronization is not there. Because of that, second process tried to give printout. Actually, second process should wait until first process printouts are completed. So actually what happens in our day-to-day life is, who has given first printout, who has given first print command, until his prints are completed, second process print command is kept in the waiting state. That is called a synchronization. If there is no synchronization, so the printing will get disturbed or jumbled. So the person who is taking a paper's printout, he will be confused whether the pages are related to first process or second process. So synchronization is also very, very important. The fourth point or a fourth function is error or exception handling. You know exception handling in your Java or OOC subject. So if when execution happens or taking place, suddenly unexpected errors may come. Okay, those should be handled properly. Say for example, I am trying to copy some 8 GB software into my computer disk. So after 4 GB or 6 GB transfer, it will tell the data is or the memory is insufficient. Okay, that is kind of error. I am executing some object file. Okay, and I have declared C equal to A plus B, and I'm using one line C is equal to A plus B, and I forgot to initialize or declare a variable called B. So this is called as error. The kernel should raise an particular error. What is the error we have done and what is the solution for that? That is also the function of kernel. So as I told, memory management. So particular process will uses a set of or a particular part of a memory. though both should be managed properly. Otherwise what happens, one process will fetch data from some other process's memory and it will give a error result. So to avoid that, what we have to do is, for which process which memory is reserved, from there only it should fetch and it should update. Okay, see the example. During examination we will give one seat for one student, if it is not managed properly, so some student may sit in a wrong place, they may get a wrong question paper and they may answer for a wrong, that will become error. So to avoid that, there should be a proper management. So then comes interrupt handler, as I told. So if one particular task is executing, high priority task comes for or occurs, it should be given a space, that is called as interrupt. There are two types of interrupt, software interrupt and hardware interrupt. Software interrupts are caused by program itself, hardware interrupts are caused by user using some buttons. Okay, time management, as I told, all processes are to be executed with respect to real time. Real time means our day-to-day life time. Okay, some of the time, most of the time, if the activity will not complete on the time, it will tell the timeout or time expired. As I told, I wanted to send money to my friend over the phone pay or a Google Pay. Within 30 seconds or 45 seconds, if the transfer does not take place, it will give. So it is not possible to do now, session is expired, like that. Okay, so now here it is measured in terms of time. These all are the 7 functions done by the kernel of the embedded system. Okay, so next we have is the tasks, process and threads. You know all these process and threads in your OS. So task means it's a broader view. A program in the execution is called as task. What do you mean by process? It's a part of a program in the execution. What do you mean by thread? Smallest part of a program. So generally what we call thread is the smallest, little bigger is a process, little bigger is a task. I hope you know the differences. Okay, so now let's start some of the points with respect to process. Okay, so process, as I told, it's a program in the execution. Presently, if program is execution, that we can call it as a process. What process will do? Process will create, process is created, it uses a resource, it will execute to generate a result. So to get a result, it is important to create a process. Also it is important to give the resources what it is expected. Once it is it has been given with the resources and the input value, it will execute and give the result. So that result should be given for a user, so user will be user work is reduced. Okay, so what is the structure of a process? Generally we think process means it's a day-to-day, like running some C program, printing, these all are the process. Okay, so what they will what a process, when a process is created, what it will do is, it's very important, it assumes itself that it has all the resources whatever is available in a computer, but this is not true. Okay, all process will not be given with all the resources available. All processes are given permission for limited set of resources, even though broader set of resources are available in a computer. Okay, based upon its requirement. Okay, if a process is created, its resources are available. When its turn comes for execution, process should utilize those resources, get the output or perform the execution, generate the result, give the result to the user. That is what work. Once the process task is completed, it should give back the resources for other process. Okay, how the process is visualized? A process will have its stack, working register, status register and program counter. So these all are the minimum data a process should have. I repeat, stack, registers, status register and program counter. So how the process is stored in a memory? If one process is created, one block of memory is reserved for that process. what it will consist of? Stack. Okay, data memory and code memory. I hope you know the difference between data and code. In our part A programs we have studied, no, add, multiply, division, these all are code. Okay, value 1 10, value 2 20, value 3 30, these all are data. Okay, so always data memory moves upwards, stack memory moves downward. Okay, so code is fixed, right? Okay, so this is a conceptual view of a process. This is how the process stored in a memory. If there are two processes, there will be two such a blocks. If there are 10 processes at a time, 10 such a blocks we can see in the memory. Okay, so next one, with respect to process, we have process states and transition from one process to another process. So what are the different states of a process? Create, just now process is created using fork command. Ready, the process is given with the resources and process is also ready to execute. So running, after ready it is running. That means what? It's whatever the resources it is requested, those are available, and it's a time to get execute. So that is called as running. Correct. So from running we have three options. What are those? Back to ready, blocked, and complete. So create, see the best case, process created, it is waiting for resources, all the resources are given and its time has come to execute. So it will run for limited time, it will give the output, the process is completed. This is called as best case. Create, ready, running, and completed. So now some average case I will show. Created, it is ready now. When it is executing, something happened. It required data from the user. The data what it is presently have is insufficient. So what it will do? It will pauses its execution. It will request for user to give the data. So suddenly that is called as wait or blocked. So until what he has to wait, the process has to wait until user will give a correct data at that time. Okay, once data is given, again it will come back to ready state, from there to the running, and data is, execution is completed. This is an average case. Let me tell you worst case. Process is created, it is ready, it has started execution. Okay, so user data is required, right? He will wait, process will wait for data from the user for limited amount of a time. So user does not give the data on time. So what happens? It is in the blocked. Again it will request user to supply the data. Again user will not give. So what happens? It will go for ready state, and there is one extra state called as abort. So what do you mean by abort? Without completion of a task, process is terminated. Who is going to perform this abort is again a kernel. Based upon 1 or 2 time repeated trial, if even after 2 or 3 trials it is not possible to complete the execution, then such a process should be aborted. I hope you know this. Okay, so there are 5 different states as I told: create, ready, blocked, that means waiting, running, and completed. So this is called as process life cycle. Okay, so here each circle is a state of a process. Each arrow mark is called as transition from create to ready. What is the transition? Inception into the memory. From ready to running, scheduler is on time. From running back to the blocked is waiting for a IO. Like this, for every transition there is a reason. So that reason will, because of that reason, transition will take place. This is also called as FSM, which we have studied in our module 4. Okay, so next is the threads. So I hope you know this part. Smallest part of a program in execution is called as thread. Also it is called as teeny process. Okay, so if, as I told, task means broader concept, Program means little less broader concept. Thread means very small concept, small view. So if I want to execute withdrawal of money from my account, for me it's a one task, but for computer hardware it is a hundreds of threads. Okay, that means what I feel single task, for computer it is hundreds of threads. So definitely computer think multi-threading at a time. Okay, so each thread will be given with separate set of resources. I hope you know the diagram in OS. Okay, so separate thread will perform its task, whatever is given for whatever the work is given for that thread, it utilizes the resources given for it and performs the task, and finally finally generates the result. Some threads will take help of IOs also, input output. Okay, some thread make use of memory fetch. Some threads may use the help of interrupt. See, like this, every task of a computer or embedded system is in terms of thread. So what are the advantages of making threads or executing tasks in terms of threads? Is it's a better performance. Why? Because task is broader view. Okay, see, very simple. Let me tell you one approach, one concept, that I want to carry 10 textbooks from my college library to the room or my home. 10 textbooks. What is a task? Taking 10 textbooks from college library to the room is a example. So for us it is transferring. How we will perform? We will take one textbook one day and take it to our home and keep it. If we take all 10 on same day, it will be heavy for us to transfer or transport. So we will take one textbook every day and take it to the home. See, this is how one task is divided into subtask and performed. So every day, that's why we can expect a better performance. Easy for synchronization, because every day we are going to take one textbook, no, on which time if I go to library and request for 10 textbook, it will take more time for him to give. So every day one task means easily he can give, and also it doesn't make the students behind me to wait for a long time, because hardly one textbook a day, no? So it will be synchronized with respect to time. Efficient utilization of resources. What are the resources? Like CPU cycles, memory cycles. I am not burdening them on the same time. So for a regular interval of time, I am giving limited amount of work. So it is also best utilization of a resource. One disadvantage is, since the threads are multiple at any instance of a time, we should handle them carefully. Otherwise, deadlock may occur. Okay, so that is what with respect to threads, right? Okay, hope you know this multi-threading OS. Okay, in a OS diagram. So the task is task or a process. When it is loaded on a memory, it will have data area and code area and data area. So first thread, it's separate stack, separate register. Second thread, separate stack and separate register. Third thread, separate stack and separate register. Same diagram you have drawn in your OS. Please recall that. Okay, right. Coming for the next, what are the thread standards? We have one example, POSIX thread, portable operating system interface. I repeat, P stands for portable, OS stands for operating system, IX stands for interface. POSIX thread. So thread means, always you remember, there will be one parent process which creates one child process and gives some work to the child. Once the child finishes, parent will also finishes. That's what simple way. Okay, so here is one program. So the program is making work done by the thread. What is the work here? Printing something called hello, I am in a new thread. Whether parent will print it or child will print, that we have to check. So now there is one function, new thread, I repeat, function new thread. It's not a main. Please remember, new thread. In that 5 times it will print I am in a new thread. 5 times. You can see here j and j0, j less than 5, j plus plus, and printf. Okay, 5 times it should print, and after every print it should wait for 1000 sleep, otherwise it will get overlap. Okay, so is it clear now what is a new thread function will do? Let's see how this is called in the main. You can see here the main program. Okay, so main, leaving this part because it's a checking whether the thread creation is success or not. If pthread creation is fail, definitely we'll get a failure. If not fail, what is meaning? Thread creation not fail means thread creation is success. If thread creation is success, this for line will work. Okay, for line. So in the for line, what I will get here, I am in the main thread. I repeat, I am in the main thread. Correct? So I am in the main thread. Then what happens? Here you can see that thread will call the child thread to join the work. Child thread to join the work. So suddenly what happens here? It joins with the TCB, task control block. You can see here task control block is here. See, we are sending one address of a TCB, task control block, that will decides whether it is a main thread or a child thread. So main thread will print it is joined with the child thread. It is joined with the child thread. Okay, so if whenever a main thread will print, every alternative time child thread will also print the output. So what main thread will print? I am in a main thread statement. Every time it is attached with the child thread. So what child thread will do? I am in the child thread environment. So like that we'll get the output. Okay. If joining is fail, definitely will not get the output. So joining should be a proper. Okay. So the last point here, difference between process and thread is with respect to resource allocation, process always expect a new set of resource, whereas a thread means it uses already existing resources. Okay, resource sharing, in generally resources are not shared between the processes, whereas between the thread definitely the resources like heap and data area are shared. Okay, so what is the difference between process and thread with respect to address is the process will have separate address space, whereas a thread will share the address space. Okay, between process the communication happens using IPC, inter-process communication, whereas the threads will freely communicate with each other. No need of communication protocol. Context switching, the process context switching is slower and thread context switching will be fast. So this is what the difference between processes and threads. Okay, so that's it for the day. Remaining, okay, one more point I will include. This is a smaller one. Multiprocessing and multitasking. Multiprocessing and multitasking. So hope you know the difference between multiprocessing and tasking. The multiprocessing is ability of a hardware, that means CPU, to execute multiple tasks at a time. Multitasking means ability of a software. Who is a software here? OS. Okay, please remember the difference between multiprocessing and multitasking. Multiprocessing means ability of CPU or a hardware to handle multiple processes at a time. Multitasking means ability of software to handle multiple works or processes at a time. Okay, so that switching between multiple processes will take place successfully and they will get executed on time. Okay, so always expect more multitasking than multiprocessing, because we can write a software, right, for multitasking, we can give more work to software. What happens if we give more work to hardware? Definitely system cost increases more. So if we reduce multiprocessing and increase multitasking, the hardware cost becomes less and the product becomes good with most efficiency. If we increase multiprocessing and decrease multitasking, for less quantity of work we have to give more cost for the hardware. Okay, so types of multitasking. Cooperative multitasking. If one process is executing, remaining process will not force it to finish or to swap out. There will be mutual adjustment that among the tasks only they will decide who has to finish first, who has to finish next, and what is their time of execution. Everything is decided by themselves. That is called as cooperative multitasking. So what do you mean by preemptive multitasking? When a process is executing, okay, another process with a high priority comes, means already executing process should come out and it should give the space for new process with high priority. So that is called as preemptive. You have studied SRT, shortest remaining time, and priority algorithms in your OS, same concept. So non-preemptive means what? Once a process is given with a resource, until its finish, no other process with any priority or anything should not come to the should not affect the earlier process. That is called as non-preemptive multitasking. Okay, so up to the first four points we have finished today, and the next concept we will continue in the next class. Thank you.